Hey everybody, thank you for joining me for today's webinar. Today we're going to talk about how we run benchmarks to prevent and detect performance regression in the AWS SDK for Java 2.0. My name is Zoe Wan. I'm a software development engineer for AWS Java SDK. I'm really excited to be here showing you our benchmarking process, and let's get started. Here's the agenda for today's session. First, we're going to give a brief introduction to AWS SDK for Java 2.0. We will talk about why do we need benchmarking, followed by the results and findings from our benchmarking process. And after that, we will deep dive on the SDK benchmarks and learn how our SDK benchmarks work. After that, we will talk about how do we run benchmarks internally. And in the end, there will be a Q&A session. AWS SDK for Java 2.0 was launched 2018 November. It is a rewrite of AWS SDK for Java 1.0, and we have added many new features, such as non-blocking I/O and pluggable HTTP client implementation, so that you can switch to use different HTTP client. Out of box, the SDK supports 3 different HTTP clients. For synchronous SDK client, you can use Apache HTTP client or Java HTTP URL connection client. For asynchronous SDK client, you can use Netty HTTP client. The Java SDK 2.0 is open source on GitHub, and we are very active on GitHub, so you can check out our GitHub repo and feel free to create issues and feature requests. Java SDK is a library used by a lot of customers to interact with AWS services. As performance is critical to most of the customers, we always prioritize tasks to improve the SDK performance. So let's talk about why do we need benchmarking to achieve that. First of all, benchmarks allows us to baseline key components in the SDK to understand how our current code to perform. With the baseline data, we can continuously monitor the performance to ensure we provide a consistent performance to the customers. In addition, to provide a low latency, high throughput performance in the SDK, we need better visibility into the SDK code execution to identify potential bottlenecks and improve them. The other reason is to prevent performance regression. There are mainly 2 sources of performance regression. The first one is SDK code changes. In the past, we've relied on code reviews to catch any suspicious code that looked like would cause performance regression. While that works most of the times, it is not 100% reliable. It is possible a simple line of code change get overlooked and end up causing increased latency in customers' application. And the other source is from dependency upgrade. The SDK has a few external dependencies, such as Apache HTTP client and Netty HTTP client. Because we don't own the third-party libraries, when we upgrade dependency, it is really difficult for us to evaluate the performance impact to the SDK use of the libraries. Benchmarking allows us to detect performance regression by running the benchmarks against every new change and comparing the data from the new change with the baseline data. If the new data is worse than the baseline, that means there might be a performance issue in the new change, and we can go into the new changes to find out. With that information, we can isolate the latency issue and root cause and find out its root cause really quickly. When we upgrade dependencies, we can run the benchmarks to see if there's any issue. If there is an issue, we can report it back to the external library maintainers, and help them find out the root cause and verify the fix. This would not only prevent latency issue for SDK customers, but also non-SDK customers who are also using the libraries. We've seen why we need benchmarking. It's time to find out the results and findings from the benchmarking. One example is from our recent dependency update, we were able to identify performance regression in one of our dependencies. So after we updated the version, we ran the benchmarks and we found out some of the benchmarks were generating less throughput compared with baseline. So we reported the issue to the library maintainer and helped narrow down the issue and verify the fix after they push out the changes. Another example is performance improvement code changes. We were able to use benchmarking to verify the performance gain with informative data. We compared the benchmarks before and after the changes, and we were able to tell how much % the new version was more performant. With this data, we can encourage customers to benefit from the performance gain by upgrade their SDK version. As a bonus benefit, the SDK metrics also provide insights on how to tune the SDK configuration. The baseline metrics are stored in a JSON file. It's also available on GitHub, so you can check out the numbers to see how SDK perform under different use cases. One interesting thing is how much faster the SDK client can be by simply switching to use OpenSSL for SSL provider. To give some context, you can use different SSL providers when you are using Netty client, and you can pass it through the Netty client builder. There are mainly two providers. The first one is JDK SSL provider, which is using Java SSL engine. The other one is OpenSSL. We have benchmarks to compare the performance of using those two. And from our baseline, using JDK SSL engine, you can get to around 200 operations per second. And switching to use OpenSSL, you can get around 8,300 operations per second. And that's roughly a 15% increase in throughput. Again, with this data, we can give guidance to our customers to prefer OpenSSL in their application to get the performance gain. We've seen the results and findings of benchmarks. Let's deep dive on the benchmarks to see how it works. SDK benchmark harness was built using Java Micro Benchmark Harness, or JMH. JMH is a toolkit provided by OpenJDK project for performance measurement purpose. JMH takes care of JVM warm-up and code optimization and provides relatively reliable data. Our benchmark code is also open sourced. It's in the same repo as AWS Java SDK v2, and the module name is SDK-benchmarks, and you can go there and check it out. The benchmark module contains a set of benchmarks that cover different use cases of the SDK. For HTTP client layer, we have benchmarks using different HTTP clients to make API calls to a local mock server. If one of the benchmarks is getting different data, we know where we should look into. We also have benchmarks that measures performance for serialization and deserialization of AWS request and response objects. The SDK supports a few HTTP content types. such as JSON and XML. Our benchmarks cover for all the supported types. Okay, so we're gonna do a deep dive on the code to see how the code look like. As you can see, this is one of our benchmark. It uses SDK Apache HTTP client and to send out requests to a local mock server. The reason we use local mock server is to isolate the network latency and just focusing on the SDK performance. And this class has many JMH annotations. JMH is annotation based and very easily to write a benchmark. And what it does is it runs 3 warm-up iterations to make sure JVM is warmed enough to measure the performance. And for the measurement iterations, it has 5 iterations and 10 seconds per iteration. We use 2 forks, and the benchmark mode is throughput. There are also other modes available like latency or sample time. You can adjust the iteration number based on the environment you are running the benchmarks. And this class looks very similar to a JUnit class. It has setup methods and teardown methods. In the setup method, we create the Apache HTTP client, and we use this is our mock SDK client used for testing. We pass it SDK HTTP client pass it to this SDK client through the builder. And in the teardown method, we close the client and to release the resources. There are 2 benchmark methods here. One is sequential API call, which is to make requests sequentially. The other one is concurrent API call, is to send concurrent request. And what the benchmark would do is it continuously hit those 2 methods to see how the max number of operations per second it can get. To trigger the benchmarks, there are 2 options. The first option is to run it from your IDE directly. And you can see there's a main method within this class. So to run it, we can just hit run. First, it would try to build it, and now it starts running. And those are the JMH configurations. And the benchmark is currently running. The benchmark code method is currently running is concurrent API call. First, it's going to do a bunch of warm-ups, and after that, you would do the measurement iteration. So let me show you the other option to trigger the benchmark. Stop it. So here, so we can trigger it from command line. First, we need to build the module. To build it, we run maven clean install and specify the benchmarks module, and do a also make to build the dependencies as well. To save time, I already built it in advance. What the command does, it would generate a benchmarks jar, and you can run it directly. So let's go to the folder, SDK benchmarks target, and you can see this is the benchmarks jar we're going to execute. So to trigger it, we can just do java jar benchmarks jar, and we can specify a benchmark we want to run. So let's just do the same, copy the name of it, and click hit. It will start running the benchmark from this command. And we can also do if we want to run all benchmarks, we can just run it, just leave out the name and run all the benchmarks are available under that module. JMH is smart enough to find out all those methods marked with benchmark annotation. You can also do something fancy to override the command, override the GMH configuration. You can do a help to see what configuration you can override. For example, you can override the number of measurement iteration, which is defined in that class, and you can override other options here. Because it's going to take some time to finish all those benchmarks, so I'm going to show you the data I got from my previous run. So this is the output of the benchmark for all benchmarks available in the SDK module. Under benchmark module, it lists the name of the benchmarks and the benchmark method name. And this column is just a provider value. It's an optional parameter and only applies to some of the benchmarks. And this is the benchmark mode. We have throughput and sample. The most interesting value is this score here. The meaning of it depends on the mode we are using. For throughput, it's operation per second. And for sample, it's millisecond per operation. As we mentioned earlier, you can see the performance comparison between OpenSSO and JDK. And for a concurrent API call, we can see it's more performant, as well as sequential API call. OpenSSO is more performant than JDK. Okay, so let's go back to the slides. As a recap, let me show you how to run SDK benchmarks locally. First, we need to build the benchmarks module by using the Maven command here. And then to trigger the benchmarks, there are two options. The first option is to use the executable jar, and you can just run a specific benchmark by specifying the name of the benchmark class, or you can run all benchmarks available under that module. You can do something fancy to override the GMH configuration within that class. For this example, it runs 3 warm-up iteration and 1 measurement iteration and 1 fork. The other option is you can just trigger the min method within each benchmark class from your IDE. However, according to GMH site, this is less preferable because depending on what IDE you are using, you might need to do additional setup for your IDE, and the data generated from IDE is less reliable compared with the other option. We know how we run benchmarks locally, so how do we run SDK benchmarks internally? When we run benchmarks internally, we use a different command. It's Maven execute command. It's defined in the POM file under that module. What it does is it runs all benchmarks using the current code base, and then it generates a test report. After that, it compares the report with a baseline report, which is a JSON file in the same repo. And finally, it fails if there's a benchmark with lower score. So we just run the benchmarks and to find out which benchmark fails, and we know where we should look into. We use AWS Code Build to run benchmarks to ensure the data from every build is directly comparable. And we run benchmarks as part of the release process to make sure there's no unexpected regression introduced into new versions to cause performance impact to customers. We also use benchmarks as a quality gate to block any changes that fail the benchmarks from merging into master. Thank you for coming to today's session, and I hope you enjoy it. Here are some links you can learn more. You can go to the JMH site to learn more about how JMH works. You can also check out our benchmarks code and run it by yourself. We also have a blog post that contains detailed steps of how to run benchmarks. Thank you again for your time. And now it's time for Q&A.